If you're new to the channel, welcome. And if you're a returning viewer, welcome back. Today, we're going to be discussing AutoGen and whether or not AutoGen is actually worth the hype. Now, I have developed a lot of prototypes with AutoGen, and I'm going to say right off the bat that I don't think that AutoGen is ready for building production-ready applications as of now. And look, this isn't me trying to denigrate AutoGen as a framework. I actually think it's an excellent framework for research or for building hobby type projects, or even for building prototypes. But for building customer facing applications, I don't think that we are ready for AutoGen yet. And I'm going to get into the details of that in this video. As always with my videos, there's going to be a technical blog accompanying this video, and it will be available in the description to this video as soon as it is published. We're going to walk through a use case today that I've developed in AutoGen that uses a multi-agent framework for multi-hop question answering. Now, multi-hop question answering is one of those things that is really tricky for LLMs to do well. And actually, I've had a lot of clients that have built chatbot-like interfaces, for example, in the legal domain, where the chatbot has fallen apart when it comes to multi-hop question answering. So it's a problem that really needs to be solved. And AutoGen, or autonomous agent frameworks that use multiple agents, seem like they could be a good solution to that. So I've built a proof of concept, and we're going to be looking at that in this video, and we'll be picking it apart and seeing where it breaks down. Before I proceed with the remainder of the content, if you do find this content useful, it would help massively if you subscribe to the channel, like, share, and comment on this video. Thank you, and let's get into the technical details. Before we dive into anything really technical, I think it makes sense at this point to talk a little bit about what multi-hop questions are. Multi-hop questions can be seen as questions that require you to pull information from different sources or disparate sources in order to answer that question. And this is quite common when you're building RAG systems, for example, where you might have knowledge that is across many different knowledge bases, and you need to be able to acquire that knowledge either sequentially or linearly to answer those questions. Look, I think it's best that we take a look at some examples to give you a better idea of what multi-hop questions look like. I'll put up some examples on screen now. Okay, so on screen, we've got some examples of various types of multi-hop questions. And as you can see, they range in complexity. So we have some questions here, like this first one: who succeeded the first president of Namibia? That has 2 hops. And the reason that has 2 hops is you need to understand who was the first president of Namibia, first of all. And then secondly, you need to understand who succeeded that president. So there's 2 hops here. The first hop you can do by answering the question, who was the first president of Namibia? And the second hop you can do by answering who succeeded the first president, which you'd need to know from the first question. So that's what we mean when we talk about disparate data sources. The answers to those questions might not be in the same data source. So you'll need to be able to work across multiple hops to answer that question. And multi-hop questions can also take on different graphical structures. So you can see the question graph here is linear, but if you focus your attention on the third question, what you can see is this is actually not linear, it's non-linear, right? It is taking 2 parallel nodes and joining onto the same node. So if we take a look at the question, it says, when was the first establishment that McDonaldization is named after open in the country Horndean is located? All right, granted, look, this is a manufactured question to make it have this kind of parallel graph structure. So I understand if it doesn't sound like it makes sense, but bear with me, let's just talk through it. So the first point is you need to know what is McDonaldization named after, right? And that's how they kind of break it out. That's the first top. The second one is, which state is Horndean located in? So these 2 things are at the minute unrelated, right? So they're coming from parallel or disparate data sources. We can gather these without, you don't need to know the answer to the first one, for example, to get the answer to the second one like it was in the first case. So we have that kind of non-linear or it's not in series, it's operating in parallel. And then the last question is, when did the first McDonald's open? And to answer this question, you need the answers to both the first and second questions. So this is a non-series, or this is a parallel multi-hop question. So it takes that graph structure there. And we have different complexities of graphs that we can see here. So that's what it is to have multi-hop questions in a nutshell. So hopefully you can start to see where this might come into play if you are working in a domain like finance or legal, for example, or anything else that requires knowledge retrieval at scale. Okay, so we should be comfortable with multi-hop questions now. Next step is I'll talk a little bit about the multi-agent workflow that I've developed to answer these multi-help questions. So I'll warn you now, this is going to be a whistle-stop tour. It's going to be really fast. I'll talk firstly about the architecture of it. I'll pull something up on screen, and then I'll go through the AutoGen code at a blistering pace, just so you know what it is like to set this up in AutoGen. And then we're going to get into the fun part of seeing where AutoGen breaks. I've designed a relatively simple workflow to tackle multi-help questions. I'll talk you through it now. What you should see on screen is an architecture for that workflow. We get a user query in, which will be a multi-help question. And then it goes to a planning agent. And that planning agent, the job is to break out the question into its different hops. Remember the questions that we saw in the paper I showed earlier. And you could understand from that you need to break out multi-help questions into different hops in order to answer them. So that's the job of the planning agent in a nutshell. And then it has access to a web search tool. So that web search tool goes online and tries to retrieve the information required to answer those questions. Once it has done that, it is passed to an integration agent. And the job of that integration agent is simple. It's supposed to synthesize all of those responses from the web search tool and the planning agent and decide whether it's okay to actually report for a response or whether there are gaps that need to be addressed. And that's where this feedback loop comes in here. So the idea is that the integration agent is supposed to provide feedback back to the planning agent, and the planning agent can adjust its plan or adjust the way it breaks down a question to find the relevant information through the web search. Once the integration agent is happy with that, it's passed on to the reporting agent, and the reporting agent takes all the information from the integration agent and creates a response. And that response provides citations from the websites the information was pulled. That is the workflow in a nutshell. And we'll get onto the code itself to implement this next in AutoGen. Now I'm going to do the whistle-stop tour of the Python script that I've used to define the agent workflow in AutoGen. I appreciate that some of you may want to get into the code in a little bit more detail. And if that's you, I implore you to sign up for my AI engineering takeoff course. If you sign up, you're going to get access to some of the free modules that I release on YouTube, but you'll also get notified when I release the projects that allow you to get hands-on with some of these coding projects I take you through. It's perfect for you if you're trying to step into the field of AI engineering and you want to get real practical experience. You also have a nice portfolio of projects to take to an employer. That will also include the project I'm demonstrating now with the AutoGen workflow, with also a fancy front end on the top of it. If that is you, I implore you to sign up to the AI Engineering Takeoff course. I have the Python script for the agent workflow I showed earlier on screen now. The agent workflow is pretty simple. It's set up in AutoGen, and there's a few parts to this. So there's the main Python script, which is on screen now, and that's where I define all of the agents. There is also a prompts script, and that's where I've written all the prompts for the agents, and it just follows the logic I outlined in that agent workflow. So it's probably worthwhile just pulling up the prompt scripts so you can have a look at that and see where that logic works out. So we have something that dictates the workflow here, and then we pass each of these prompts into the main agent workflow that's in the agent.py file. Okay, I'm going to do a whistle-stop tour of the code that I use to define the AutoGen agents in that workflow. Right. So I'm just going to skip straight to the agents. A lot of the stuff you see up here is pretty standard. This is acquiring API keys for OpenAI models and also the API key for a Bing search engine. And I didn't mention this in the architecture, but the search tool is using the Bing search engine. So that's why you need that Bing API key. If I step into the agents, the first thing to understand about AutoGen is there are various different classes of agents, and they're used for different purposes. The classes of agents I've used here is the user proxy, and the user proxy is important because that's how you can actually execute code. So that's how I execute the code behind my Bing search tool that I've written. There is the assistant agent, and those are powered by LLMs, and they usually do things like generate text. So all the text generation type tasks are done by the assistant agents. And last of all, you've got the group chat manager, and that acts to route all of the messages between the agents. What's interesting about AutoGen is that every agent sees the entire context of the conversation. If that doesn't make sense to you right now, it will make sense later on when I start demonstrating how the app works. So just stay tuned for that, and don't worry about it. If it doesn't make sense now, it will make sense later on. Defining the agents is really easy from that point once you understand what agents you need. So I have gone through and defined my user proxy first because there is some code that I want to execute, which is the search tool that does the Bing web search. And then the planning agent is the one that actually breaks down the initial multi-hop question into simpler components and essentially creates a plan or a strategy for answering that multi-hop question. Recall that the planning agent actually has access to a tool. So it has access to the web search tool that is defined later on in the script. I'll get back to that once we pass that point in the script, but just hold that in your head that the planning agent has access to the tool. Next is the integration agent, and that assesses the output from the planning agent after it's used the web search tool. and it uses it via the user proxy, and then it gets that response and decides whether the response is suitable to actually go on and provide a final answer to the question. And then last, of the assistant agent types, we've got the reporting agent, and the reporting agent uses the output from the integration agent to send the final report to the user. Recall I said that the user proxy is actually responsible for executing code, and that's where we assign the responsibility here. So we do this by this decorator. We say the user proxy, and we register it for execution. Recall as well that the planning agent is actually responsible for providing the questions to search on the web search tool. That's where we register the planning agent here. So the workflow knows that it's looking for the responses from the planning agent in order to use those for web searching, and the user proxy itself executes that. So we do that via these decorators here, and then we have the web search tool defined here. So and then next you set up your group chat. So the group chat is it's kind of a context that allows all of these agents to communicate with each other. So I think I mentioned it earlier that the agents all see the entire context of the chat. If that's not clear, it will become abundantly clear when I start demonstrating it, but that's how it's facilitated through this group chat context. And then you have your group chat manager, which is key because that allows you to interact with the group chat. And that is pretty much it for your AutoGen workflow. It is quite simple to set these workflows up. AutoGen makes it really easy with those different agent classes. All right, let's get into the exciting stuff. We're going to test where these AutoGen workflows break, and we're going to test them against the multi-hop questions that I introduced earlier. So what I found in this investigation is that LLMs at the current stage they are not the best at logical reasoning. And it might seem like that because they seem to work well for a lot of the common tasks we have. But when tasks get a bit more complicated, you see that the LLM's ability to reason through those tasks does break down. And nothing draws that out more than the AutoGen multi-agent frameworks. I'm going to show you how unreliable those LLMs are in actually completing those workflows end to end. And we'll start off by using GPT 3.5 Turbo. We'll see where that breaks, and then we'll move on to using GPT 4 Turbo. We'll see where that surpasses the performance of GPT 3.5 Turbo, and see where eventually even GPT 4 Turbo breaks. And you'll get to see the picture of why I'm skeptical about using AutoGen for customer-facing applications right now. What you should see on screen now is the front end to the application. So this is the front end to the multi-agent workflow that I've set up. We're going to test it out with some of those multi-hop questions that I introduced earlier in the video. The first one we're going to use is a free-hop question, which is about Billy Giles. And the question asks, what currency is used where Billy Giles died? So this is a free-hop question. To answer this question, it's suggested that what we need to do is we first need to understand what location did Billy Giles died, which is Belfast. The second thing we need to understand is what part of the UK is Belfast located. And then the third thing we need to understand is what currency is used where Belfast is located. All right. So there's a linear approach we take. We need to have the answer to the first question in order to answer the second question. And then that answer to the second question is used to give us the answer to the final question. Okay, so let's just get into it and let's test out GPT 3.5 Turbo to see how it approaches this. So I'm going to send that question through. I'm going to wait a little bit for the process to complete, and then I'm going to talk through what's happening here. So we have got a final answer. I'm just going to start from the top and show you how that process completes. So we send that into the agentic workflow here, and it goes to the planning agent as we've defined. The planning agent breaks out two questions. So it says, where did Billy Giles die? And then the currency used in the country of Billy Giles's death. So those are the two areas that it's assessed. And that is quite direct. It's actually assessed less than 3 hops, which is fine. Then it goes to user proxy. So remember that I said the user proxy is the agent that executes the web search function. So the planning agent decides what questions to ask, and we can see the questions the planning agent has come up with here. So where did Billy Giles die? And currency used in the country of Billy Giles's death. We can see that. And then it's passed on to the user proxy. The user proxy actually executes on that by putting those into the search engine and then returning results and visiting those pages, and gets a summary for us from those pages of the things that are relevant to that question. So we can see here, and we've got the links there too. And then that's passed on to the integration agent. And the job of the integration agent is supposed to take all of that information returned from that search and then decide whether or not it's enough to answer the question. And if it is, it passes it on to the reporting agent. And we can see here that the reporting agent has answered the question and said the answer to that is British pound sterling. So the currency used where Billy Giles died is British pound sterling. That is the correct answer. So we hit terminate there and we exit that agent workflow. So you might recall that I said the group chat manager actually orchestrates all of this, and you can see here because what happens is every agent sends a message to the group chat manager, and that's how all the agents are able to communicate with each other. So the group chat manager almost acts like a router between all of the different agents. And it is also true that every agent sees the entire context of the conversation up until the point that it starts interacting. Obviously, this is quite token intensive, and I'll get into some of that a bit later. But that's you can hopefully that's a bit clearer now. Every agent sees the entire context of the conversation, and that's how they're able to effectively communicate with each other. On the surface, it seems like GPT 3.5 did this quite well. However, what I would say is that the reporting agent is actually prompted to return citations. And I have noticed whenever I use GPT 3.5, I can never get the reporting agent to actually return those citations. That is starting to show GPT 3.5 breaking in this workflow. It hasn't completely broken because it's returned the right answer, but it actually hasn't returned the citations as I requested. Okay, let's test the same question with GPT-4 Turbo and see if it does any better. So GPT-4 Turbo obviously is a more powerful model, and I expect it to return the right answer. But let's see how it returns the answer, which is obviously important too. So GPT-4 is a bit slower than GPT 3.5 Turbo, so it will take a little bit longer to work through, but it has actually done that. Now let's go up and let's see how it's done it. So it's actually identified 3 hops, the planning agent. So it says identify Billy Giles, which seems sensible. We need to understand who he is. Determine the location of Billy Giles's death, which also seems sensible. And then identify the currency used in the location of Billy Giles's death. So this is kind of more aligned with the research paper in identifying 3 hops. It's not exactly the same hops that the research paper outlines, but still, that's absolutely fine. Let's move on to see how those searches are implemented. So the first one is who is Billy Giles, and then the second one is where did Billy Giles die? Okay, so those are the 2 searches that it has suggested, and we've done those searches, and it comes up with who Billy Giles is. You can see there's some context here, and then the second one is telling us where Billy Giles died, and you can see it's pulled, and this is all retrieved from Wikipedia. The next thing is the integration agent, and the integration agent has done its spiel on whether it believes we can answer the question or not. So it's basically just doing some synthesis here, and if there is anything missing, it will flag it, but it's not flagging anything here. And lastly, on the reporting agent, so given that Belfast is located in Northern Ireland, which is part of the United Kingdom, the currency used there is the British pound sterling. And then we've got all of this additional context here, and most importantly, we actually have a citation. So we can visit that citation, and what we can see is Billy Giles, and we can see his death was in Belfast, and Belfast, we know the currency of Belfast is the British pound sterling. So I must say that has worked quite well. Although that was quite a simple question, we'll move on to something a bit more complex. We'll move on to something that has not just that kind of series of hops, but something that maybe has a parallel graph component to it as well, and see how the multi-agent framework handles that. Okay, so let's try something a little more difficult. Let's try something that isn't just a linear graph. Let's try something with some kind of parallel nodes. We'll try this question. When was the first establishment that McDonaldization is named after open in the country Horndean is located? All right. So to answer this question, we need to take 3 hops once again, but there are some parallel hops here. So the first one is, what is McDonaldization named after? The second one is, what state is Horndean located in? So remember, the significance of these parallel hops is that they're not really related. They don't feed into each other like the last example. They're completely unrelated. So what is McDonaldization named after? The correct answer to that is McDonald's. Which state is Horndean located in? The correct answer to that is England. And then you need both of those answers to feed the final hop to get the answer to the question. So when did the first McDonald's open in England? And the answer to that is 1974. Great. So we have that established. We understand it's a bit more of a complex structure. So let's test it out. Let's see how it works with, first of all, GPT 3.5 Turbo. So we've got the model up. Let's put the question into the chat window and we'll ask. We'll give it a second to run through. Okay, so we seem to have gotten to the end of the workflow, and just kind of as I suspected, it hasn't actually delivered an answer for us. So it's we can say here the reporting agent has sent a message to the chat managers just saying terminate, but hasn't actually given us a response. If we step through the logic here, let's just see what it actually identified. So it actually identified 4 hops. So it said, identification of McDonaldization origin. So determine the location where McDonaldization originated and establishment it is named after. Okay, I mean, I think that's quite direct. I'm not sure it's going to have too much success, and it didn't. So let's just see how it works through establishment opening date. Find out the opening date of the first McDonald's restaurant, which is established, which is the establishment associated with McDonaldization. So it already knows the answer to that, which is fine. Some of these things are ingrained in the model. Location of Horndean, identify the country where Horndean is located. So at least it understands it needs to do that. So the connection between Horndean and McDonaldization. So establish any historical or contextual link between Horndean and the origin of McDonaldization. So what questions did it say? So it says origin of McDonaldization and opening date of the first McDonald's restaurant. And then there's another set of searches it's looking for. So location of Horndean and connection between Horndean and McDonaldization. Right. So it stepped through and we can see it has pulled some of that context through. So it's run that first search via the chat manager. By the user proxy. And McDonald's founded in 1940. However, it seems as if it hasn't actually run all of the required searches. And you can see this here because the integration agent calls it out, right? So the integration agent says the information gathered from the search results provides insights into the sub-questions related to the origins of McDonaldization and the location of Horndean. So to address the specific connection between McDonald's establishment and the country where Horndean is located, further investigation may be needed. So it's saying that we need some further investigation, but it actually doesn't go on to do that. And there goes my kind of first observation or point about these AutoGen workflows. The workflow is established such that it is supposed to actually go back to the planning agent and find the answer to those questions that it doesn't have, right? Find those answers it doesn't have, but it doesn't. Instead, what it does is it skips straight to the reporting agent. Now, I have played around with the settings in AutoGen, so there are settings where you can decide how each agent executes its job. And for me, it doesn't seem to matter how I play around with those settings. I can't get consistent feedback loops in there. And, that is when you're doing complex tasks, you do need those feedback loops and you need the ability to be able to self-correct. So it doesn't work with GPT 3.5. You can see that here. We didn't get an answer to the question. But what about with GPT-4 Turbo? Let's see what response we get to that same question. So I'll move the model over to GPT-4 Turbo. I'll wait for that model to load. So we're working with GPT-4 Turbo now. And let's ask the same question. So just give it a minute to run, and then we'll talk through the output again. Okay, so it looks like we've got to the final answer with GPT-4 Turbo. Let's step through the actual output and see how we got there. So scrolling back up to the top here, where we asked after we loaded GPT-4 Turbo. So the planning agent obviously has chosen to break this out a little bit differently to GPT 3.5. So what it said is, what is McDonaldization and which establishment is it named after? So that's kind of more aligned with what we see in the research paper that the question comes from. That's what we see. And then it says, in which country is Horndean located and when was the first establishment named after McDonaldization opened in the country where Horndean is located? Great, so it's established those 3 hops, which is excellent. And then look at the tool calls. So we've got what is McDonaldization and which establishment is it named after? And then in which country is Horndean located? Those are our search tools. So now we're stepping through. We are looking at the tool responses. So we can see that we've actually returned some context for each of those questions. So I believe that is for the first set of questions. What is McDonaldization? There we go. So that is for the first set of questions. And which establishment is it named after? And then we've got Horndean. It tells us it's a small village in Hampshire, England. Great. Then moving on, so the integration agent has some feedback for us. So it says, based on the information gathered, tells us a bit about McDonaldization and tells us where Horndean is located. It says, now to complete the answer to the original question, we need to find out when the first McDonald's restaurant was opened in England. Let's proceed to gather this information. So that's great. So it's moved on to reporting analyst, the reporting agent, and now we need to find out when the first McDonald's restaurant was open. So notice it didn't exit the chain here, which again is interesting. So using GPT-4, it obviously understands that it hasn't got the answer to the question. So it goes back, and that's the feedback loop that I put in. It goes back to the planning agent. The planning agent then changes its search, and it says, when was the first McDonald's restaurant opened in England? And notice that is actually the question we need to get to the answer. And hopefully we return a response here. So we've got October 1974, and then the integration agent does its spiel, and I believe it says that's okay. And then going back to the reporting agent, we have our answer. So it says, first McDonald's restaurant in England, the establishment McDonaldization is named after, opened in Woolwich, South East London in October 1974. And I can tell you that's the correct answer from the paper. And we have our references here. And let's just check through to see that they all work. Horndean, and then lastly, history of McDonald's UK. So that goes to the newsroom. So that's a different, that is actually a different, there we go. Yeah, so that worked quite well. So as you can see, as the question or the graph of that question got more complex when we had some parallel aspects to it, the multi-agent workflow had to actually iterate on itself and had to incorporate that feedback loop. And it turned out that the GPT 3.5 turbo model, which is a weaker model, less powerful model than the GPT 4 turbo model, GPT 3.5 turbo struggled to do that, and it couldn't incorporate that feedback into the agentic workflow, whereas GPT 4 could. So it looks good so far, but what we're starting to see is that GPT 3.5 breaks for more complex tasks, whereas GPT 4 seems to work so far, at least. Okay, what we're going to do next is we'll move on to a more difficult example. So I'll move on to something where we have 4 hops, and let's just see if GPT 4 Turbo can work through this. I'll tell you now, I already know that GPT 3.5 Turbo can't do this, so I'm not going to waste time going through GPT 3.5's output again, but let's just see how GPT 4 Turbo works. Right, so we're going to move on to another test with GPT-4 Turbo, and we're going to test a 4-hop question. And this is one of those questions that has that linear graph that I was talking about, where one question, the answer to one question feeds the next question. So I'll explain. It's a 4-hop question. The question is, when did Napoleon occupy the city where the mother of the woman who brought Louis XVI style to the court died? So it's 4 hops. The first hop is, who brought Louis XVI style to the court? And the answer to that is Marie Antoinette. And Marie Antoinette is then needed to answer the second hop, or the second question, which is, who's mother of Marie Antoinette? So who's the mother of Marie Antoinette? And that is Marie Theresa. And the answer to that is needed to answer the third hop, which is, in what city did Marie Theresa die? And that is Vienna. And then the answer is needed to answer the final hop, which is, when did Napoleon occupy Vienna? And the answer to that is 1805. All right, so you can see how those answers kind of feed through into the next question in order to get to the final response. So it's important that the model is able to pick up all of those answers, otherwise it won't be able to get to the final response. Right, so we have that established. Let's see how it works with GPT-4 Turbo. So I'm going to select the model and confirm. So remember, this is a 4-hop question. The questions that we dealt with before were 3-hop questions, and we had 2 types. We had the linear type, and then we had a type with the parallel nodes. So let's see how GPT-4 deals with our 4-hop question. So we'll wait a while for the answer to be generated, and then we'll step back through the agent trace. Okay, so we have gotten to a final response, and let's just step up and back through the agent trace and see what's happened. So we've got to answer the question about when Napoleon occupied the city. So I'm not going to read all of that, but this is the reasoning here. So we are identify the woman who brought Louis XVI star to the court, find out who her mother was, determine the city where her mother died, and then find out when Napoleon occupied that city. So that kind of seems correct in the sense that, from what the guidance in the research paper said about breaking out this question. So the planning agent has seemingly correctly identified those steps, which is good. So let's see what it calls. So it's a woman who brought Louis the 16th style to the court, and that's one of the arguments to the search tool, which is good. And then we've randomly here got Napoleon's military campaigns and occupations. Maybe it thinks there's a shortcut way of doing this, which might be it being a bit too clever here, but let's just see what happens. So we do get responses for both. There's not a lot in terms of Napoleon's military campaigns. It seems like that is a bit too general. And then we go to the integration agent, and it says it gives us some advice. We may need to refine the search for the woman associated with Louis the 16th style. This step remains contingent on successfully identifying the woman in the first question. It's true. And so, yeah, we've gotten some feedback, and it's saying we need to adjust our search. But interestingly enough, it hasn't done that. And this is what I was talking about, the inconsistency with AutoGen. So you saw previously that it was able to step back into the planning agent and readjust itself to answer the questions to get the information that it was missing. This time, it just hasn't done that. It's just gone straight to the reporting agent, and it has terminated. It's just said, well, we can't get the answer. So without additional specific information. And I haven't found a way to really get around this. I've played around with the different settings, like I've said, different prompting strategies, but it just feels right now that AutoGen is a bit temperamental when it comes to feedback loops. It's not easy to bake those in, and you can't get them to work consistently. So what I'm going to do is I'm going to try to run the question again and see if we can actually get the feedback loop out of the workflow. So I'm going to run that question again. We're using GPT-4 Turbo once again. Yep, and again, we've ended up with the same thing. So I think AutoGen also does have this thing where it caches responses. So this is likely just this exact same response that we got before. What I will say to you is I have run this question before, and I have managed to get the correct answer where it was able to I don't know if it did the feedback loop or not, or whether it just managed to get it the first time, but I have run it with GPT-4 Turbo, and it did manage to get to the correct answer. But yeah, there lies the inconsistencies with AutoGen. It just doesn't behave how you want it to behave, and it's quite hard to get that deterministic behavior when you need it. So when you need that feedback loop, either the agents just don't understand, or sometimes they understand that they need to take the feedback loop, but other times they don't. And I think that might be a problem with reasoning aspect of it, or it could be a problem with the underlying framework of AutoGen rather than the reasoning aspects of the large language models that are being used. But certainly, I think the more capable a large language model is of reasoning, the better it is at working through these AutoGen or whatever framework agent workflows. So hopefully you see what I mean when I say that AutoGen isn't quite ready for production or customer-facing applications yet. And look, granted, I know that there might be some engineers out there that know how to use AutoGen better than I do. But I will say I've built several prototypes now with AutoGen, and I've never managed to get it to work consistently in the way I need it to. And, the framework is evolving all the time. They are constantly making changes and constantly evolving the way they're doing things and adding new features. So I expect that it will evolve. And also, around the corner, we've got more capable large language models that are coming out. And it'll be interesting to see how those work with, to see how AutoGen works with those more capable models, whether they're closed source or open source. I want to discuss a few other things that bother me about AutoGen. So right now, if you do want to use AutoGen, really, I think the only model that works well with it is GPT-4 Turbo. And it comes at a cost. So that's another problem I find with AutoGen is that I can only really use it with GPT-4 Turbo, and those queries come at significant cost. So just to give you some numbers, I'll put something on screen, which should be appearing right now. And what you can see is for the simple first question that we asked, the one that was just a linear free hop question, the cost of that was around 5 cents. And you can see that cost actually linearly increasing with the complexity of the task. And that is what you'd expect. I just think that cost is a little bit high for AutoGen to be practically useful for a lot of use cases. So yeah, the cost is still too high. And that is something that's going to be resolved because ultimately the cost of these models will come down over time. So right now the cost is a bit too high. The other thing to consider is also the token rate, the rate at which tokens are sent through and processed by the OpenAI API. So OpenAI does impose limits on you. And what I figured out with AutoGen is that for more complex tasks, obviously the tokens per minute that you're sending through to the API increases. And it doesn't take much to actually start hitting that limit. And if you're building an application that you plan to scale to thousands of users, for example, you need to be very aware of token limits. So I've gone into a bit more detail about costs and token limits in the article that's linked in the description to this video. If you want to know more, then check that article out, and you'll have the graphs and tables there to show you in more detail what I'm talking about. The final point about AutoGen for me is the compatibility with open source large language models. So it's no secret that's the direction that a lot of people in the industry are moving towards, and there's many reasons for that, mainly privacy, data privacy, and also reducing costs. There's a few issues. I have tried open source models with AutoGen, and I can't get them to work well. And I think there's two reasons for that. The first one is the open source models right now, the reasoning capabilities are not there. They're not good enough to really be using these multi-agent workflows like this. The best open source model right now at the time of recording this video is Mixtral, and that is just up to par with GPT 3.5 Turbo, I believe, or maybe beats GPT 3.5 Turbo, but doesn't get to the standard of GPT 4. So that's kind of what we're dealing with when we're dealing with open source models right now. That's what we have. So that's the first point. I don't think the reasoning capability is there yet with the open source models. The second point is actually about compatibility with the framework itself. So the framework was built around OpenAI models, and there are so many hidden prompts in the framework that are suited to the OpenAI prompt format. And it becomes a pain to start integrating your open source model with open source models have their own random prompt formats, and it's a pain to integrate that into the agent workflows. I know you can integrate it easily into the inference endpoint, so they do offer an inference endpoint too. But when you actually want to build it into an agent workflow, like a group chat or something, it becomes quite difficult because I find you have to actually go into the agent classes and change some of the prompting within the agent classes itself and format that in the way that is required for an open source model. So yeah, it's a problem. It's a problem when it comes to integrating open source models into AutoGen. Those are the main things, really. Those are my main gripes, I'd say, with AutoGen. Overall, I do think it's an interesting framework. I've really enjoyed playing around with it. Like I said, I've built several proofs of concepts with AutoGen and played extensively with it. And I think it is good. I think, it's an enjoyable framework to work with. I think it's perfectly suitable for things like research or, like I said, building proof of concepts, or even just if you're a hobbyist and you want to mess around with something and get to learn how agents work with each other and do something fun. It's great for that. But would I put this in an application for thousands or hundreds of thousands or whatever, or even dozens of users to use? Probably not, because I think you'll start running into those issues that I have pointed out in this video. Thanks for listening. Listen, if you enjoyed this content, please remember to subscribe to the channel, like the video, share it, and put your own comments. If you use AutoGen, talk about your experiences. What did you gain from using it? Do you agree with me? Do you disagree with me? It would be interesting to know. Thank you. And until the next time, I'm out.